Hi everyone, so today we will doing the problems climbing stairs. So you are climbing a staircase. It's taking n steps to reach to the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? So with these problems, we can see the keyword in here is distinct ways. And this really is easy notice problems that we can do DP, dynamic programming. Just not thinking about that for a moment, we firstly can have to come up with the questions to ask the interviewers to clarify the questions. And more than that, we need to come up with an example. So as we see in here, in the example 1, we have n is 2 and the output is 2. Since there's two ways to climb to the top, the first way is just climbing one step at a time. And then the second way is two step right way. And then with number 3, n is 3 as well, so we have 3 steps. The first step is just one step at a time. The second way is just step 1 step and then step 2 step. And then the third way is just cover like step 2 step and step 1 step. It's just the reverse of the second way. So as we see in here, we can come up with questions for interviewers like, so can n be 0? And if we just return 0, is that okay? You see in here, n is larger or equal to 1, so there's no ways n is equal to 0, so it's okay. We kind of like gather some ideas about these problems, so let's move on to planning and matching step. This type of problems, we should go through more examples to kind of like form a formula. So we start with n equal to 1. So this one will have just one step, because it can just go in one step to get to the n is 1. So with n equal to 2, so we have two staircase. So one is 1 plus 1, 1 plus 1 step is 2, or we can just skip to 2 as well. So this one is 2 way. N equal to 3, so this one way. This part is 2 ways. And then with n equal to 3, we're having 1 plus 1 and then plus 1 again. And then this will be 1 plus 2, 1 step and then 2 step. And then we will have like 2 and then 1 step. And with that, we know that n equal to 3, we have 3 ways. Okay, so with that, we continue with stairs 4, n equal to 4. We have 1 plus 1 and then plus 1 again. And in here, we can combine 1 step into 2 here. And then we rearrange it. So it can be 1 plus 1 and then plus 2. We can rearrange 1 plus 1 like this. And then we can plus 2 and then 2. So we don't have any others ways. So this one is 5 way. Okay. So maybe we see the formulas in here. So n equal to 1, we have 1 way. N equal to 2, we have 2 ways. N equal to 3, we have 3 ways. And n equal to 4, we have 5 way. And so n equal to 3, we know that 3 way here can be equal to 1 way plus 2 ways, right? So it's kind of like this one is n equal to 1, and then this one is n equal to 2, right? We can check if this one also works as well. So we have n equal to 4 is a 5 way. So like that, we can have like is equal to 2 ways plus 3 ways, right? So this 2 ways is actually is n equal to 2, and 3 way here is n equal to 3. Let me sure these formulas work by adding n equal to 5. So with this, we can anticipate this. N equal to 5 would be equal to 3 ways plus 5 ways, right? So this part, I get it from n equal to 3, and this part with n equal to 4. So we know this will be 8 ways. So let's list it out to see if it's actually 8 way. So with 1 plus 1 plus 1. Okay, and then we combine it. 2 in here, and then still have, okay. Then try to rearrange it. 2 and 1. And we can also have 2 at the end. 1 and 2 at the end here. Now we move 2 at the start of the list there. 1 and 1 and 1. Okay. And then combine 1 and 1 here equal to 2, and then still 1 here. Rearrange this one, we can have 1, 2 here, just one more. So 1 at the first one and 2 at the end. Okay, we rearrange everything. So with this one, we have 1, 2, 3, 4, 5, 6, 7, 8. So it's actually 8 way. So we know that these formulas work. So after on the example, we kind of like forming the formula that the third number would be equal to the first number plus the second number, right? So with that, we will move on to the implementation step. Implement step, I will do it in Java, but I also have Python solution down in the descriptions, so please check it out if you're familiar with that more. So in the matching and blending step, we establish all the example to find the patterns in these problems. So firstly, we will having the base case. If n is equal to 1, then we know that it always returns 1, right? And then we will have the first numbers. So this first number is represent for n equal to 1. And we know that it's just have one way to step to the stair. And then we will have our second numbers, which is n equal to 2. And we know that we have two ways to do that, to go to the stair. And then we will need to have a for loop, but we will start with 3, since we already established n equal to 1 and n equal to 2 here. So with I equal to 3 here, we need it to equal to smaller than n, and then we just do I plus plus here. And with that, we will calculate the third number. So would be equal to first times the second number there. So we already have these formulas in the blending and matching step. And then we'll have to move the first to equal to the second. But we also need the second to be equal to third. Okay. After we go through all the for loop, then we know that this will represent all the steps that's with n equal to some things will be equal to. So we just return the second here. Okay, so please make sure this one work. We just will go on to the example. So we have n equal to 3 here, and then we have the first equal to 1, and then second equal to 2, right? And then we have third here. So with this one, we have first seconds here because n is not equal to 1, so we skip this. First seconds here, and then we go to the for loop. Third will be equal to first plus seconds, so it will be equal to 3. Then first will be equal to seconds, so this one get updated 2, and second equal to third, so this one updated 3. And then we go outside of the for loop, and this one will return 3, really exactly the output we want to see. So please make sure this one work. Just go through all the test case here. Okay, so this one accepted, so everything worked. With this one, we have the time complexities is O of n, since we just go through the for loop here to get to the n. So we know that this is big O of n, and then the space complexities, this will be equal to O of 1, which is a constant because we don't store anything, data structure to store anything. So yeah, make sure it works. We just submit this one. See in here, we have successfully completed the challenge. So this one is faster than 100% of all Java online submissions for these problems. So I think we solved these problems, and please like and subscribe to my channels. If you have any questions, please comment down below. I will get through it. So thank you.